Okay, so what I did first is I split it in half so that you had the Pythagorean theorem right there. So then this is 3 and this is 6. So if you have a squared plus b squared equals c squared, then c is c and 3 can be a or b. And so then you have a squared plus 9 equals 36. And if you subtract 9 from both sides, you have a squared equals 27. And so then this is the square root of 27. And to find the height, you can do another Pythagorean theorem from the outside. So then this is a triangle. So then you know that this is halfway there, so it's 3. So then the square root of 27 minus the minus 9 equals the square root of am I doing this right? The square root of 18. And what did I do wrong? I think I missed a step.
You forgot the square 27.
Oh.
No, she has the square, so...
Because it was the square root of 27.
It's just 27 because
Right,
it's
yeah,
square.
you forgot
Oh, so 27 minus 9 equals
because 27 squared.
18. So then this is the square root of 18. And so the square root of 18 is also has a perfect square factor. So then it is the square root of 9 times the square root of 2. So that is just 3 times the square root of 2. And so that is the height, 3 times the square root of 2. And the equation for the volume of a pyramid is the area of the base times height divided by 3. So the area of the base is 6 times 6, so it's 36 times 3 times the square root of 2 divided by 3. So that is just, these can cancel, or I guess you can cancel these out. So then you just have 36 times the square root of 2.
Now, here is the next step. Here is the next step for this. You had this problem, so I could show you this problem. Oh yeah. Here we go. This looks wicked fun. So here is what we are looking at. Here's what we're looking at. And Jay is going to walk around with a paper cutout right now. So go ahead and walk around with it, please.
Just walk around.
And for those of you at home who can't see this, Jay has actually cut out this shape. And when you fold it, you will end up getting, and it's going to be sort of hard to draw it. Let's see. I'm not doing a good job of it. So essentially, you will end up with a pyramid. You'll end up with a pyramid that is added to a second pyramid. And there's the base. So essentially, you end up with two pyramids that are attached. And so what are the side lengths here?
6.
They're all 6. So essentially, we are ending up with a three-dimensional figure that has 2 pyramids that are put together. Now, in our previous problem, we had 1 pyramid with the same dimensions. In this problem, how many pyramids do we have? 2 pyramids. So, if one of these pyramids has a volume of 36 times the square root of 2, what is the volume of 2 of them?
So 72 times the square root of
Thank
2.
you for waiting for me to call on you to shout out the answer, but it's brilliant. Yes, Cooper.
108 square root of 2.
Let's try that again. Grady. 72 root 2, because we are multiplying this by 2. And 2 times 36 is 72 root 2.
That's the answer?
That's the answer. Now this problem, as long as you're able to find the volume of one pyramid, isn't really that difficult. The trick in this problem is that you have to realize that this flat pattern will create 2 pyramids that are together. Once you realize that, just find the volume of one pyramid, double it, and there you go.
Why does it have those arrows?
Because it's showing that this edge will match up with this edge. This edge will attach to this edge. This
Color coordinate it so like they.
but this is something that you should be able to do on your own.
Did anyone
All
from
right.
our team get this right at state last year?
That's a trick question. I'll tell you why it's a trick. All right. So here we go. Right now, for number 7, all I want you to do is I want you to multiply out these 2 polynomials. Go ahead and multiply that out.
I will try and help you. I tried this. I did it. Oh no, thank you. Okay, so what you're gonna do? Okay, I'm probably gonna be wrong. That's just a lot of stuff. So it's x to the 4th. You're multiplying x squared plus x squared is x to the 4th, right, Tate? Yeah, so it's 2x's times 2x's, which is 4x's. So that is x 4th plus 8. I think a to the x plus 8. I have no clue. A times 3x. Right, is x to the 3rd. Plus, and then you have 6 times b. So plus 6b. B. Okay, you get this. Error. Oh no, then you have. Wow. No, I got it somehow. That's not how you do it. X cubed plus. Oh, and then you have bx cubed. That's just b. Why? Do you want us to? Oh, you have to go back the other way too.
But wait a second. So here we go, guys. So we have multiplied this out. And now it's time to look at the question. Let's look at the question. So if we multiply these 2 trinomials together, we will get a product that is x to the 4th plus mx squared plus n. Plus n. For integers a, b, 9, and n. What is the product of m and n? So in other words, we know that we have whole numbers only. That's what integers mean. And we know that we have to multiply the coefficient for the quadratic term by the constant, or the y-intercept. So m is a constant, it's a number, n is also a number. And so I'm looking at my multiplication, and it's a bloody mess, right? I have a's, I have b's, I have I think I have a AB somewhere, maybe. No, I don't. Yeah, I do have I have a BX.
3bx.
And so I also notice that I have x to the fourth, x to the third, x squared, x, and no x's. But yet it tells me right here, do I have any x to the thirds? No. Do I have any x to the first powers? No. Okay, so that means that when I combine these two terms, I have to get 0 x to the third. What is the value of a? The value of a has to be -3. So right now I can say that a is equal to -3. Now I also know that I have no x's, plain x's to the first. I know a is equal to -3. So therefore I'm going to rewrite this problem. I have 3bx plus 6 times -3 times x. So really, this is just 3bx plus -18x. And I know that these two terms have to cancel out. What's the only b value that's going to make this a true statement? 6. So I know b has to equal 6. Great. So now that I know that, I can plug in a value for b, I can plug in a value for a, and I can end up figuring out what is my m value. I can also figure out this value. I want you to do that right now. Go ahead, substitute in the values we know, and let's figure out our m value and our n value. Go. Instead of b, write 6. Instead of a, write -3. It is positive 6 because we need to have a positive 36x.
Could we write the answer as mn? Equals bx squared plus 3x. What's the product of m and n?
Yeah, very funny. Ha, ha, ha.
Wait, what did you say?
He said, what's the product of m and n? mn.
Mn. Could you write that?
If you put m and n together, it means you multiply it together.
M&M. M&M.
What?
Do you know that M&M?
I just get you. Yeah.
Can I get some water?
Marshall Mathers, maybe?
But if you put that, that would be correct. That would technically be correct. It would technically be correct. Putting M&M. What is the product of M&M?
Okay, 5, 4, 3, 2, 1, 0. So, what do we have instead of b?
6.
6, okay. So we have 6x squared. What do we have instead of a? -3. So we have 3 times -3x squared. And we just have plain old 6x squared. So what's another way of writing 3 times -3? What's -9, all right. So instead of this, let's have -9. All right, so what is 6x squared minus 9x squared plus 6x squared?
3x squared.
3x squared.
But you still have 3x. Oh no.
What is my m value?
3.
M would be 3 because my coefficient of my quadratic term is m. So I know m equals 3. What's another way of saying b? 6. So I have 6 times 6. What is 6 times 6? 36. Okay. And so this is my n value. And we want the product of m and n.
108.
3 times 36 is?
108.
108. So therefore, my answer is 108. Yes, Jay?
Can we do another one of these problems so I feel more? A equals 3 and B equals -6.
Excuse me?
How do we know it's not A equals 3 and B equals -6?
We know that A has to equal -3 because if this was a positive, 3x to the third plus 3x to the third would be 6x to the third. So the only value for A that would cause the x to the third power to disappear would be -3.
But then it would equal -1x.
No, no. If this, because -3 plus 3 is 0, because they are
Oh, yeah,
opposites.
they're added.
Yes, sir.
Why did we line it up like that? I feel like I should know, but
So I lined up the problem, the products of these separate multiplication problems like this, so that I had similar terms stacked. Because I can only add things that have the same variables. So I wanted all of my x to the thirds on top of each other, all of my x squares on top of each other, all of my x's vertical.
One, like, isn't it each time you like move over one like term, you can also move like one line to the right?
Yes. So yeah, so it's just an easier way to organize your multiplication.
Can we do another one of these problems?
I appreciate that you believe that I'd